Now that we have created the store, it is time for us to actually create the layer. Layers are the data that we will visualize either in GeoServer itself or using any client application such as OpenLayers, Leaflet, so on. Now, layers can be broadly divided into two types. One is vector and one is raster. And again, inside vector, we can divide it into different types of geometries such as line, point, polygon. If you click on your layer list, you will see different types of icons over here. These icons allows us to understand which type of layer is this. For example, first one is actually a raster layer. You can see that the symbol looks like a pixelated image. While the second one, if you can guess, is a point layer. The fourth one is a WMS request coming from outside. Then we have polygon, and here we have line layer. So this becomes very easy for you to understand. Once you upload your own layer, you can also verify whether the geometry type or whether the layer type is correct or not as per your requirement. To edit any layer, you can simply click on the layer title and you will get into the form. Now we will have a look at how to add a new layer, and by doing that you will automatically understand the form of also editing the layer. So to begin with, I will be first of all uploading a vector layer. So from our last lecture we created a earth data all natural data source where we had a directory of shapefile directed to the GeoServer, and now let us deal with this ports as a point layer. I will simply click on publish, and what do we mean by publish is that we want to take this feature set from this store and publish it as a layer. Alright, once this is done, then it will open a 5-part form for us to fill information. Most of this information is optional, but some is absolutely required. So if I go over to save button now, and if I click on save button now, it will immediately give me an error that lat long bounding box is required. So you can see that you cannot directly just click on publish and publish the layer. Now let's have a look at some of the basic attributes or some of the basic things that we can change. Name and title. Name is the one that we will frequently use along with workspace to identify this layer. So it is my personal recommendation that you should not have space bar in it. So we can do something like ports. Then we have enable. Once this is checked, this means that this will be accepting all types of requests. So let it be a get map feature or get feature request, anything like that. Then next we have is an advertise. Advertise will work just as fine, but it will just not be available in any get capabilities document. So again, if you remember from our workspaces video, we had an isolated workspace as a checkbox that when we click on that, that workspace will be there in GeoServer, but it will not be there in a capabilities document. This is the same thing. Once I remove this advertised, the layer will be available for us to use, but it will not be there in a capabilities document. Then we have a title. This is basically a human readable format. So you can write all world's ports and this will work just as fine. You can also give title in different languages if you need to do that. So you can basically just select the language of your interest and you can give the text context, and you can add multiple languages and save this. So this will be helpful for you in a capabilities document. Now we have abstract. So abstract can be considered as one of the description of this layer. So I can write something like I got this data from natural earth and it contains all ports. Then we have keywords. By default, GeoServer will put some of the keywords for you, but you can add your own keywords anytime that you need. This helps you to create a catalog of layers. So imagine that all this data will be available to you in a capabilities document, and then using these different keywords you can organize your data better. So I can write something like ports in English, of course, and I will add. So like that it will be added. And same way I can also remove existing keyword. So sometime you have to refresh in order to see the result. Next we have is a metadata link and a data link. So if this is not working for you, that's not a problem. I will tell you how exactly you can get this working. But under the hood, the logic of metadata link and a data link is that you can add some of your URLs that you want your user to see, and then again this will be available in your capabilities document. Then we come at a very important topic, that is coordinate reference system. So for a file such as shape file, chances are very high that you will have a projection file with it, which will have the native SRS information available. So in the native SRS, whatever data that you upload, whatever coordinate system is attached to that data will be available over here. And then we have a declared SRS. Declared SRS is GeoServer's own coordinate systems list, which contains all information right from the active boundaries to extent and allowed boundaries, things like that. So it is always recommended that you select a declared SRS. You can simply click on find and you can see, and then you can search for whatever SRS that you need. So for example, if I search for 3857, I will get this. If I search for 32643, I will again get that SRS. Once you select declared SRS, then you can handle that how exactly this situation should be managed. So SRS handling can be done by three ways. First is a force declared, which is going to be by default in most of the cases. So what do we mean by this is whatever SRS we have used in the declared one, we are forcing GeoServer to use that. Now you might get confused that if the native SRS and if the declared SRS is same, then why should we force it? Reason is, it is not always guaranteed that from wherever you are getting your data, you will have all the metadata of that coordinate system attached to that. Thus, if we declare it, we will be 100% sure that all the metadata and all the extra information that we need along with the coordinate system is here, because this is, as I said again, this is a directory maintained by GeoServer itself. So by declaring force declared, we are 100% sure that our data is going to be projected in a correct format. Then we have reproject native to declared. This comes in handy when you want to reproject your data on the fly. So for example, even though my original data is in EPSG 4326, if I want to present it as 3857, I can do that. So by doing this, my data on the front end or even in the capabilities document will actually be presented as a 3857. This helps us to reproject the data on the fly. But this setting is not a very good way to deal with the big data, because in case of big data, GeoServer will need a significant amount of time to convert your data from one coordinate system to another and then present it on the front end. The last option is keep native. This is the option that you should only use when you are 100% sure that your native SRS contains all the metadata and required extra information that we need from the coordinate system. So personally, I would avoid this and I would only select between first and second depending upon what I want to do. Now I will again go back to force declared and I will search for 4326. Next we have is a bounding box. So here we can select, either we can compute a bounding box based on our data that we have, or we can just use the bounding box of the coordinate system. So I can either do this or I can do this. Then we have a latitude longitude version of this bounding box. Next we have is a curve geometric control. So if your geometry is going to have curvature in it, you can actually turn it on, and the reason why you should do this is when we will output our data as a GML, it will actually show it as a curve GML rather than a line string GML. Now what do I mean by that? If I simply go to layer preview and look at any of the line layer into a GML format, you will see that the data is actually presented as a GML line string. While if we make it as a curve, then it will be presented as GML curve, which is the correct way to do this. For us, this data doesn't have any curvature in it, so it doesn't matter if we tick it or not. And here you can give the tolerance that at what level the geometry should be converted into curvature. So this can either be a meter or a foot. So I can give something like 1 meter or 15 feet, something like that. Next is a feature type details. Here all the columns that you have in your data along with the geometry will be shown. This helps us to have a double check on all the metadata, the type of information does it hold, whether this can have a null value, and what is the mean max occurrence of this. With the latest version of GeoServer, we can also customize this attribute. So for example, this NEID, maybe this is not the correct way for me to present it in the front end. So I can actually change it to something like Earth ID and this will still work. So once I do that, I can actually save and this will work. Finally, in the data tab, the last option that we have is restrict the feature on layer by CQL filter. If you're not familiarized with CQL, that's not a problem. In upcoming video, we will exactly see what does a CQL filter means. In a simple words, CQL filter is like adding a filter to our data. So for example, I can have something like just show me the data which is in any specific country or matching any specific name. So what do we mean by that is if you have used Postgres or any other database, you know that you can create an SQL view where you can add some condition and then only data satisfying that condition will be visible. This is exactly the same. Now if I click on save, you will see that our layer is saved and this is our layer. We have all world port and then this is the layer name, earth underscore data colon ports underscore all, and then this is the store name, and you can see the coordinate system is 4326. Now if I head over to layer preview and I will simply try to preview this layer one more time. So I will click on open layers, and now if I click on any one of the port, you will see that now we are seeing the earth ID, the exact column name that we gave while creating the layer. Now we will go back to our layer one more time. And now if you open metadata link, it will work just as fine. So it is recommended that you should either use ISO format to give the type of the layer, but again this is not mandatory. You can give any URL that you want. So I can again add all the URLs that I want, and again the whole idea of using these URLs is that these will appear in your metadata and then you can use it in capabilities document anywhere that you want. Now let's come to the second tab, which is a publishing. Here we define that how exactly this data should be visualized or should be shown using OGC standards such as WMS or WFS. First one is response cache header. Once this is ticked, for given amount of time, the GeoServer will not request same tile twice. So if I do it as a 60 seconds and if I load some data, then that particular data will be used for next 60 seconds. We will not use it again. Then you can select which layer do you want to keep in a get capabilities as a root layer. So by default we will keep it as WMS global setting. Then we have layer settings enabled, and here we can select that this layer should only be used with the OGC standard WMS and not with the WFS. This is a setting that generally people will not use because they want to use their data in vector as well as in a WMS format. So You will mostly keep it as unticked, but again, this is an option. Then next you have is a WFS setting. So per request feature limit, how many features should GeoServer return whenever a request is made? So this request can be get feature request or get map request, anything like that. So by default, when you keep it as 0, that means that you are not setting any limit to it. Next we will see is the WMS setting. Here we define that what type of styles we want to give to this layer. When we keep it as a queryable, that means this will be used in get feature info calls, and this layer is queryable. Then we select a default style for this layer. So you can select any default style that you want, or you can also select additional styles which then can be presented as alternative styles using a capabilities document. So for example, I will select some of these styles as my selected styles, and once I save this, and if I go back to my layer preview and reload it, here I will be able to select different styles. Of course, this style will not work because these are not the styles made for point, but this will just give you an idea that okay, this is how it works. Now we will go back to our layer one more time. Under publishing, the default rendering buffer. The default rendering buffer and default interpolation method is something that we will explore when we actually have a look at the WMS OGC service. Then we can add some more metadata to it, such as authority URL, layer identifier, some attribution text. All this data that we fill will be available in a capabilities document. Similarly, we can also make some settings for KML format, such as default regenerating attribute. So what should be that? Then default regenerating method and features per regenerated title. All this information will be useful when we output our data as a KML. Next we have is a dimensions tab. So if your data contains a dimension which has a time or elevation, you can use it over here. So by default you can see that we cannot select time because we have no attribute where this type of data is found. But elevation, you can select the attribute that you want, and then it will be used as an elevation. Or you can also define your own custom vector dimension. So if I give any name, it will open the form and it is going to be the same form as we see for elevation. You select the attribute, you select the end attribute optionally, and you select units. Tile caching is something that we will see when we go to the chapter of GeoWeb cache. Finally, we have a security. Inside security, again, if you remember our workspace layer, this is going to be the exactly same. You are going to have different roles and you can define that which role can do what things with this layer. So some of the layers, some of the roles can read this layer, some of the layers can also put information in this layer. All this can be selected by security over here. And as always, you can always grant access to any role which is a least level of security, so it is not recommended. So this is how you can play with different properties available for vector data in order to create the perfect data format that you want. Once you save this layer will be available for us to visualize in layer preview. Now to create a raster layer, the method is more or less same. So if we go to any raster layer, you will see that more or less the file is going to be same. We are going to have name, title, abstract, keyword, metadata, coordinate system. But the only difference is that now we also have a coverage parameter options available. Here we can select that what should be the tile size. So you can either have something like 256 by 256 or maybe 512 by 512. It totally depends upon you. And then depending upon how many bands your data has, this table will be created. For example, this layer has red, green and blue, so RGB, all three bands are here. So we can select that what should be the value of null, what should be the minimum and maximum range. By default it will be infinity infinity, so all the data that we are going to have will be visualized. Then under publishing you are going to have somewhat similar options that we had in vector data such as caching, root layer, layer security. Finally, we can select that what type of interpolation that we want to do. Again, more on this when we actually get into the WMS. And you can then select what type of format of this data output should be. So by default, we have GeoTIFF, GIF, PNG, JPEG and TIFF. You can also select more formats such as ArcGrid and Image Mosaic. Here you can again select the style, the default and the available. Finally, the dimensions over here are going to be the same, where if you have any elevation data or time data attached to it, it will be visible. Tile caching, we will have a deep look at tile caching in GeoWeb caching lecture, and security again is going to be the same that we checked with the vector data. So this is the only potential difference that we have between publishing a raster data and publishing a vector data. Now it doesn't matter what is your store, either it is a post GIS or a single shapefile or a directory of shapefile, or as a raster data it can be a world image or a GeoTIFF or a GeoTIFF coming from a cloud. The way to create the layer is going to be same. Now to end this lecture, we will also cover the topic of layer group. Layer group allows us to visualize multiple layers as a one single entity. So for example, if you check the current available layer groups, for example Tiger NY, here you will see that different layers available on our GeoServer such as Giant Polygon, Poly Landmark, Tiger Road and POI all will be visualized in a single go, so that from a front end it will look like this is a single layer. If I search for Tiger NY over here, you will notice that the type, the symbol is different, and when I open this will have all the layers in it as a single layer. To create a layer group, we will simply head over to layer group and click on new layer. Here you can give the name, the title, abstract and which workspace does this belong to. Now before filling the bounds, you can actually select all the layers that you want to include in this particular layer group. So for us, let's try to do earth data with cities and ports, water areas and airports. Okay, now we are going to have these 4 layers. I think now we are going to have these 4 layers, and we will give it as a name earth data group, earth data, and now we will generate bounds. So the reason why we selected layers first is now I can actually generate bound based on these layers. So GeoServer will automatically calculate the bound based on all the data that we have in all of these layers. Now if I save this and head over to my layer preview, I can search for earth data, and you can see that we have this layer group symbol, and we can open this. You can see that when we click, we can get the data from cities and we can also get the data from airport. Again, inside layer group, we have publishing tab with all the same attributes that we have seen, such as caching setting, root layering capabilities, some metadata attached to it. Then we have tile caching and security. So this works as very similar to the layer. So I hope this lecture was clear to you, and now you can create your own layers using vector data or raster data and also able to create your layer group. Thank you.